Hello friends, welcome to my new session on sampling distribution of sampling mean and standard error. Now these two topics are basically required when we learn sampling. Sampling is a very important topic in the field of statistics and especially in case of the business statistics where it is used. Now what do we mean by sampling? Now sampling is basically used in case of factories to test the samples. It is a little bit different from census. In case of census, what we do, we used to test the whole population. But in case of sampling, we not only test the whole population, but we just take a few samples. For example, a bulb manufacturing company suppose manufacture 10,000 bulbs a day. Now it is not possible for a statistician to test the whole population of here the 10,000 bulbs we are considering as a population. Now it is not possible for the statistician to test the 10,000 populations. So in this case what we do, we take a few samples. For example, we take 30 samples of the bulb. Now this 30 sample will give me the an average characteristics of the whole population. Now this sampling distribution of the sampling mean, what do I mean by this? We are all familiar with the term this term mean. Now mean it is denoted by mu. So, now suppose we draw a graph like this. Now suppose this represents a graph. Here the frequency of 1 is up to this, 2 is up to this, and it will go on like this. Suppose we imagine that mu is the mean of the whole thing. Now to sample this, we will take sample of 2. Like for example, sample of 2, 1 and 2, 2, 3, 3, 4, and so on. Now this sample we are taking, if we this sample 1 and 2, the mean of this one is 1.5. Again a sample 2, 3, the mean of this is 2.5, and we go on like this. Now in what we get from sampling distribution of the sampling mean, if we break the term, what we get, two terms are we need to know, the sampling mean and sampling distribution. Now these are the means. The mean of all these are the means of this sampling. Now the sample we get, these are the distributed in different samples. Now when we plot this in a graph page, we will see that it is distributed almost like this one, that is a bell curve, or what we call is at a normal curve. So this all is it will now if suppose this is the mean, the maximum number of the means of these samples will be concentrated in these areas. Okay, in these areas will be concentrated, and this is called the normal. That is the distribution we call this as a normal distribution. Now if we increase the number of samples, that is if we take 3 at a time, 1, 2, 3, again 1, 2, 4, again 3, 2, 4, like if we go on like this, the mean of this one will be 6 and 3, 2. we will go on like this. Now we will see in this case that the curve will become like this. That is, it will become a little bit more pointed. And observe one thing carefully, that the variances have reduced. In the previous case, that is this, the one which is marked in the black, the variance in this case was up till this, about the mean. But the variance, the standard deviation, that is the deviation from the mean, have reduced. That is the deviation reduced, so the variance will obviously reduce, but the pickedness will increase. Now this, and remember one thing, the mean will always be is equal to a mu. What is mu? That is the mean of the total population. This, it is always will be, this point is always will be equal to the mean of the total population, that is mu. So it will be distributed around. This is the basic principle of the central limit theorem. Now sampling error, the distribution, it will again, if we increase the, suppose we take another sample, like for example I take draw a graph like this. Now suppose I take the sample of, this is 10, 1, 2, this is 15. This is, suppose I say 12, 3. Now in this case, whatever will be the mean, that is we denote it by mu, we also get the similarly, mean will be, I think, 10 plus 24 plus 45 whole divided by 32, 47. This will be the mean. I'm sorry, it will be 37, which will be equal to 9. It will be 2 point something, the mean. Now this mean will be given here. Okay. Now in case of sampling, when we are sampling the total set, totally we are having the sum of 3, that is we are having 37 number, we are having 37 raw data, what do we call. Among this we have to sample. If we sample taking suppose 2, we get, usually what we do, 37 C 2 to get 2 number of data. But observe one thing friends carefully, we will get this result will be 36 into 37 by 2 or 18. But we don't need all this, because see the number of is 1, 2 and 3. So if we take 2 sample, we will either get 1, 2, 1, 3 or 2, 3. Okay. So the mean of this will be 1.5, the mean of this will be 2, and the mean of this will be 2.5. Now if we distribute it, we will see that it will be distributed like this. So suppose this is 1.5, this is will be 2 This is 2.5. This will be 2.5. Again, if you used to take the more sample, then we will get something like this, and the points will be distributed like here. We will get the normals. So this is the practical application of the sampling distribution of the sampling mean. Now coming to standard error. To know standard error, we have to understand that while we are sampling, we have to consider the errors too. Because for example, we want to know that how many number of Mercedes owners are there in a city. Now to get the sample, there will be some errors. It is obviously that there will be some errors. So to consider this, we take the standard error. Now what is standard error? Standard error is basically related to the static. The standard error is basically related to the static. What is static? There are two things which you need to know in the statistics, that is parameter and statics. Parameters are related to parameters. This is related to population. And static this is related to the sample. Now coming to standard error, what we can understand from standard error is that this term is actually related to the statistic. Now as I have shown you before, that the term parameter represents the different types of the different properties like the mean, median, mode of the population, while the term statistic represents the same thing, that is the mean, median or mode and skewness of etc. of the samples. Now standard error, suppose I am showing you the basic concept which is related to the mean. The standard error of the mean, it is denoted like this, sigma x. Now why I am showing you, and it is, the formula is this one. Well, sigma is the standard deviation of the population. Now the standard error of the mean, it is considered because when we are taking the samples from the total population, we know that there is going to be some errors. To consider those errors and to take those errors into account, we have to calculate this standard error of the mean. Now this is given by standard error divided by root over of n. This root over of n is the number of samples taken. So clearly from this equation, we can understand that more the number of samples you take, the lesser are the chances of error. Now since this standard error, that is the sigma, this standard error, the standard deviation, this sigma represents how much the populations, how much the population is deviated from the actual population mean. So this standard error of the sample represents how much the sample mean is deviated from the actual sample mean, total mean of the samples of the sampling distributions. That is, if we take the samples like 1, 2, 3, 4, 5, 6 and all, how much they will deviate from the actual mean, as I have, that is this one, it will be considered by this. Now as I have told you before, that this mean mu will be equal to mu of x. This mu of x represents the mean of the sample, mean of the whole samples. How much they will deviate from the actual sample, it will be considered from this. Now if this value, if the mean value was 5, this will also be equal to 5. So if you like my video, please like and subscribe my channel, and if you think some changes are to be made, please comment on the comment box. Thank you.